So you might wonder, why do we learn about uniform distribution and uniform distributed random variables? I'll show you a very, very interesting example of uniform distribution itself with a simple code. Okay. So you might have, when you're learning C programming or Java programming or any other programming language, you might have heard about this term called pseudo random number generators. Pseudo random number generators, right? Um, what they give us. So for example, I think in C, in stdlib.h, you have a function called rand, which gives you a random number, right? So random numbers are uniformly distributed to start with. Again, that I can generate random numbers which are non-uniformly distributed, but if it's not specifically explicitly called out, most random number generators are uniform generators if it's not explicitly called out. Now let's see why they're useful. Okay. So for example, I can import in Python, I can import random and I can say print random.random. What this prints is, it gives us a value. So if it gives us a value between 0 and 1, and it picks a value uniformly at random. Okay, what it means is it's basically taking 0 and 1, right? It's taking 0 and 1. It will pick any value here uniformly at random. So once it could, so if I plot the distribution, if I generate, let's say 1,000 numbers from this and plot the distribution, this is the distribution that I would get. Okay, and these numbers are uniformly generated. This is the probability value and this is my random variable x. Okay, now I can generate a random number like this. So let's actually execute this. The first time I run this, I got 0.105. Every time I run this, I'll get a different value. Every time I run this, I get a different value in the interval 0 to 1. And these numbers are randomly generated with uniform distribution. Okay, this is very important. Okay, now you might say, why is it useful to start with? Now let's take an example. Okay, let's from suppose our problem is this. Suppose I have 150. Suppose I have n data points. I have a data set with n data points, and I want to sample. Suppose I want to sample m points from this. Okay, I want to uniformly sample. What does uniformly sample? Sample uniformly. What does uniformly sampling mean? It means each point in this, in my initial data set, let's assume this is a data set of n points. Let's assume this is a data set of m points. Each point should have the equal chance of belonging to my d dash data set. That's what I mean when I say sample uniformly, right? Suppose if I have, let's say my n is 150. Okay, this is my first point, this is my second point, my third point, so on and so forth. This is my 150th point, right? When I'm sampling, let's say 30 points from this, each point should have equal chance of belonging to my data set d dash. That's what I mean when I say sampling uniformly. This is the word, this basically means that, okay, we'll see that we have to use, how to use uniform random distribution when something like this happens. Okay, let's take a data set. In this, I'm just loading the iris data set. Okay, from scikit-learn, I'm importing the data sets. I'm saying iris equals to dataset.load iris, and d is iris.data and d.shape. So this is my iris data set with 150 data points. So my n equals to 150, and I have 4-dimensional data. Just to quickly recall, these will be petal length, petal width, sepal length, and sepal width. Okay, so I have 150 data points. Now imagine if I want to sample 30 points randomly from this 150 point data set. Okay, let's assume that's my task. How do we do it? Of course, there are one-line commands for you to do it in NumPy, also in Pandas. But how is that implemented internally? Okay, suppose if I want to sample, if I want to pick 30 points out of my 150 points, how do I do it? So let's go down and see some simple code to do that. Okay, so just to quickly recap, suppose my data set is let's say x1, x2, x3, so on and so forth, x150. I want to do a sample operation and create d dash, which is x1 dash, x2 dash, so on and so forth, x30 dash. And how do I want to sample? Any point here should have equal chance of belonging to my data set. Okay, how do you do it? So let's see simple code on how to do it. And here we will use the uniform random sample. Sorry, uniformly distributed uh, uh, random variable. Okay, so my n is 150, my m is 30. So let me generate a new variable called p, which is m by n. Of course, this is going to be 0.2, right? 30 by 150 is going to be 0.2. Okay, I'm creating a list which is a sample data which is empty to start with. Now what I do is I go through each of these points. So I have my p value as 0.2. I have my p value as 0.2, right? Now I'm going from the first point to the last point. First I go to the first point. Okay, and then I generate a random value now. Okay, and I know that this generates a random value between 0 to 1 with equal probability. With equal probability, right? Which means what is the chance that it will generate a value which is less than 0.2? Less than equal to 0.2. See, if random.random is less than equal to 0.2, the chance that it will generate a point which is less than equal to 0.2 is 20%. Because since I have 150 points and I want to generate a data set with 30 points, what is the probability of each point belonging to my data set D dash? It should be 30 by 150 because I want all of them to have the same probability, right? Which means for any given point, now imagine if I'm doing a coin toss. Okay, my coin toss is not a 50-50 coin toss. It's basically a biased coin now. Okay, so when I generate my random number, if the random value, what is the probability that the random value is less than 0.2? It's 20% chance, right? So whenever it is less than 0.2, I add it to my sample data. So here I'll generate a random number. If that value is, let's say, 0.15, I'll add it to my data set. Second term, if this value is 0.3, I will not add it. If this value is, let's say, 0.17, then I'll add it to my new data set, and so on and so forth. Now, since the probability of generating a random number, this random number, we know that these random numbers lie between 0 and 1. And the probability of generating a random value which is less than 0.2 is 20%, which means there is a 20% chance that each of these points will belong, that there is a 20% chance that each of these points will belong to my data set D dash. And that's what we want. Why is it 20%? Because 30 by 50 is 1 by 5, which is equal to 20%, right? So whenever you want to generate a random sample uniformly at random from a larger data set, your uniform random sample, this is nothing but this is u0 comma 1. This is a random variable which is distributed u01. This is one of the biggest applications of uniformly distributed random variables. Okay, they're extensively used in simulations, in randomization, and things like that. Okay, now at the end of it, my sample data. Okay, here comes another interesting part. I wanted to run you through this code. So if I run you through this code, let's see the outcomes that we get. Okay, there is a bug somewhere. Let's go fix the bug. Shouldn't be hard. D is not defined. Why is D not defined? Okay, let me run this then quickly. Let me quickly run this. Let me go step by step. Let me run all of the cells. Okay, now it goes. So here you get an output which is 29, not 30. Remember, you got an output 29. Okay, because random number generators are not perfect. Okay, so next time I run this, okay, sorry, let me rerun this. Next time I run this, I got 33. Okay, next time I run this again, I got 29. So every time, sometimes you get even values as small as 22. Sometimes you got 36. Okay, so here, even though I'm creating a random sample, the size of the random sample need not always be 30. This is important. This is basically the size of the sample data or the length of the sample data. It need not always be exactly 30. It will be roughly around 30. Okay, so this is one way for you to generate roughly 30, not exactly 30, roughly 30 random samples from your total data set. Okay, and this is one of the biggest applications of uniformly distributed random variables, especially the continuous version, especially the continuous random variables which are uniformly distributed.